Alrighty, good evening, guys. Welcome to Groups 9 final demo video presentation. So my name is Joshua Soriano. I am the project lead. I'm an electrical engineering major, and my role in this whole entire system was the LED subsystem and the audio amplifier subsystem.
I'm Vince Dell. My major is electrical engineering, and I'm the hardware and power lead.
I'm Devin Snyder, an electrical engineering major, and I was the lead on the capacitive touch and the microphone subsystem.
I'm Ryan Halk. I'm an electrical engineering major, and I'm the lead for the companion application and the communication protocol between it and the helmet.
So the purpose of the DPHP project was to have a bunch of fun entertainment systems integrated into one helmet. So this helmet can also be used as, let's say, like a decorative display at home, or we can actually have the wearer use it to go and present it at social events, kind of like a wedding or a DJ set, a party, or any type of event venues that you can think of. Now, we wanted to go with this project because we wanted something fun to show that engineering projects don't have to solve world problems. Now, some engineering problems can just make the world a little bit better by having something that's creative and on the entertainment side. And so the engineering goal of this project was having a bunch of systems integrated that are embedded. So we have like the LED control, the microphone control. We also have the capacitive touch sense. We also have power routing and power mapping and Bluetooth control through the ESP32 all into one system. Now, the inspiration of this project came from Daft Punk. I don't know if you guys heard of them, but they're a musical duo that did a lot of DJing back in the 2000s. And we had a lot of inspiration through their music and the aesthetic aspect of their helmets. And the cool thing about their helmets is that they use those helmets to kind of protect their personal identity. And then the public eye had these type of helmets to actually match, like, a physical identity with their music. So we went with this helmet design, which is Thomas. He is the silver guy, a part of Daft Punk, which is the two duo. There's the silver guy and the gold guy. This is Thomas. And we wanted this helmet design mainly because the visual aspect of what we thought in mind would be best for a senior design project like this.
Yep.
So now that I'm finished introducing our project, I'm going to hand it off to Vince so he can go on with the power system.
First, our helmet is being powered by a 12-volt rechargeable nickel metal hydride battery inside this backpack's pocket right here. Our charge controller PCB, which is the LTC4011, is receiving power from our battery right here. And our charge controller PCB delivers power to two of our buck regulators. The first buck regulator is our LM2576 3.3 volt buck. Our second regulator is a 5 volt LM5117 buck regulator. Our LM2576 regulator powers our MCU, microphone, and capacitive touch. Our 5 volt buck regulator right here powers our LED matrix visor, LED rings, battery indicator inside, and the speaker right here. Our MCU board right here is an ESP32. We chose an ESP32 MCU because Dr. Reeks recommended it. It is low cost, and it has a Bluetooth module, which we use for our app. My teammate, Devin, will explain the capacitive touch.
Yes, so in order to have a set of external controls on the helmet that can be used to change through some of the animation modes and presets of the LED maps without having to rely on the app, we have a capacitive touch controller, the MPR121 capacitive touch controller, which has it can be configured for up to 12 electrodes, multi-touch of those electrodes, and has configurable touch and release patterns. And for the electrodes themselves, we use a conductive flex PCB material from Adafruit. The right electrode, or the left and right electrodes, because we only have two, are located in the center of the ears. And the right pad right here goes forward preset or group, and the last one goes back preset or group. So by holding for 2 seconds, you can go to the next group. and holding the left pad for 2 seconds goes back a group. All right. And then holding for tapping left.
So the microphone is inside, is it?
Yes,
Very low,
microphone's-
okay, low, very low, okay.
Then so tapping right goes to the next preset, tapping left goes to previous preset. And then by holding for 4 seconds from any mode, we can go to microphone mode. And then the last thing is the battery indicator, which is located at the top on the inside of the helmet. And so by holding both of these for 2 seconds,
See the battery indicator at the very top.
Okay,
that you
Yeah.
can see the battery
Yeah.
indicator. So that's it for the passive touch. And so then for the microphone mode.
Yeah.
The microphone mode on the inside of the helmet, there's a Max 9814 audio amplifier breakout board connected to an electret microphone. We were planning on using an I2S microphone in the beginning, but after all the problems it gave us, we consulted with Dr. Way and Dr. Weeks, and we used a ADC analog amplifier. And so we just have a few different sound presets that can be used to take in sounds and then display it as some different cool presets. And then Joshua is going to explain how to use it.
So for the LED subsystem, we decided to go with the pre-built 8x32 matrix that we bought on Amazon. Now, with this matrix, it allows us to show majority of the visor opening, as you can see in the front of the helmet, and it allows us to also have a good enough resolution for good enough static images and animations that we want to show, and text to be shown fully throughout the whole entire visor. Now, another thing that was pre-built was the LED ears that are located on each side of the ear within the helmet. Those are pre-built PCBs that have 24 LEDs. That's what also those PCBs were also bought on Amazon, and they're programmed right now just to be rotating clockwise, respective to each ear, and having basically a rainbow effect, because we just kind of wanted to lessen the amount of load that we would be putting through the power subsystem. Now, with the entire LEDs subsystem, we know that we have to power it with a 5-volt technology. So we have the 5-volt regulator, but the data itself is not actually being used through the 5 volts. The ESP32 actually sends 3.3 volt logic, but the LED subsystem needs 5 volts. So we use a level shifter in between the ESP32 and to the LED subsystem to convert the 3.3 data logic into 5 volts, so the LEDs can actually be programmed and show all the animations and static images that you can see. So the reason why we went with the LEDs subsystem as pre-built is because, unfortunately, JLC PCB had some issues with making our final PCBs, as if they take a long time since they were flex. We were planning on making flex PCBs that had enough holes for you to see through, and they had a little bit of a bigger resolution, which was an 8x34 with different types of LEDs, and also pre-built panels, so it can actually go on the side where there's a gap right here. And then also we were going to have a custom LED ear so we can have more functions with LED ears. So that will be it for the LED subsystem. Now for the audio amplifier subsystem, that introduced us another subsystem, which is the audio amplifier subsystem. Right here, we have this custom board that's made here, like you see, and that it is the audio amplifier has that LM386. That IC is powered by the 5-volt regulator, and it sends the signal data to the 2 speakers that we have on each side of the ear. Now, right here, we have the potentiometer to increase the volume or decrease it. And so as you can see, when I come around here, any single time that I want to basically have the helmet say a certain preset or audio file, we move it to the next preset or previous preset. And so we increase the volume. This should say previous preset. It's kind of hard to hear because we decided to make sure that the gain was low enough for a user to wear it and not obviously, mess around with their ears because we didn't want it too loud. And so this is next preset. And then also, we also have audio files for the mode changes. Back to microphone mode and it said microphone. So now with these audio files, we made sure that we wanted audio wave files actually to be saved within the ESP32 because we wanted to minimize as much basically workload on the ESP32. Instead of having something to have audio decoder or anything, we wanted just free audio files that we generated with AI on a website. So we went on AI, we had the AI generator grab our text and make it into an MP3 file. Then we went to another website, made that MP3 file and converted it to a WAV file. So we have a bunch of WAV files inside the ESP32 and it communicates with the capacitive touch and also the app, which I'll
Alright,
Brian.
So the companion application for the helmet is based on the Flutter programming language, and it connects with the helmet through Bluetooth Low Energy. See here, and you can see the app right here. So effectively,
Oh, right here.
this is just basic startup screen. It's not connected to the helmet until I press this, and effectively, it's going to search for the BLE server. It's going to connect. It's going to exchange security information because this is encrypted and authenticated, and it already has the data in here. So effectively, it goes straight to the app screen, and here's just the home screen. And here we see two icons. We have a battery percentage level sent over from the helmet, and we also have a charging indicator, but we can't really demonstrate that here. So effectively, just simple. It shows you the current mode, shows you different display modes you can go to. Currently, it's in sound mode. And you can change it.
Come on.
But if you want, you can go to a specific mode, go to graphics. Kevin, if you will. A little delayed, but yes, the helmet and the app are in sync with one another. You can change it, and then you can also change the modes with the app. It's a little bit faster. And if you don't want to cycle through them like with the capacitive touch, you can go through the many different presets. Just go to whatever one you want. Oh. Of course, there's also text mode. This one's interesting. As you can see, we have a total of 9 texts right here. It can go through there, but if you want to, you can add in your own, like for example, say intro, sure. Send the text, and now it is displayed on the helmet, and you can save it. And after saving it, now it's on preset 10, which didn't exist before, but now it does. And if you want to, you can also instantly change the color, either from just using the slider, or alternatively, you can create your own, save them on the app. Do that. You can also
Good.
say go to animations mode. You can do.
All right, you can control yourself now. Is that right?
But effectively, what I just did, is if I go to groups mode, I can go to there.
Okay.
And as you can see, it has the preset that we just added.
Yeah.
You can go through them. And here you go.
And so now we're going to show you a live demonstration of what it looks like when we're, let's say, in a party setting.
One more time.
Change the mode. Okay, good.
One more time. We're gonna celebrate. Oh yeah.
So you still can
Alright,
see us,
stop the
right?
dance. dancing. One more time, we're gonna celebrate. Oh yeah, alright, don't stop the dancing. One more time, we're gonna celebrate. Oh yeah, alright, don't stop the dancing.
Really good.
One more time, we're gonna celebrate.
For all the
Oh
reviews, do
yeah,
you want to ask a question now? Yeah.
one more
Go ahead.
time.
All right. Okay, I think we see enough. Let's ask question now. Yeah. Thank you. Thank you very much. Really appreciate it. Nice.
Well, there's no dance cohesion. You fail on that part. From Win's pandemic.
Yeah.
Yeah.
All right. Let's.
Really, I was doing you all a favor by sitting in the chair.
Yeah. Okay. Good. And now, and Dr. Gong, go ahead.
I think they did a very
Yeah.
good job.
Yeah.
Yeah, the dancing part can be improved.
Yeah.
Question.
Okay. Very good.
They show what they want to do and they successful.
Yeah.
Good job. Thank you.
All right. Thank you. Yeah.
Question. Actually, what's the purpose of using the microphone?
What's the purpose of use
For
microphone?
the microphone. Just because the microphone mode, it acted the animation in it is actually synced up with the
Yeah.
microphone.
It's different mode change. They're actually audio. Remind them.
We wanted to try and have a mode that reacted in real time to the
Yeah.
audio input.
Yeah, so the microphone mode, yeah, it's just to detect sound, show it on the LED matrix.
So they said that this microphone is going to get some information from outside, right?
Mhm.
Like me,
Mhm.
I say hello.
Mhm.
And what does this do to my hello?
It's supposed to display it as like an audio view. So, or we do have some other modes, but it's mainly supposed to detect like the sound level.
So I mean, the output will be kind of random.
Not random, but it's mainly supposed to detect like how loud it is.
So you're actually adding those mode, reminding you inside the audio, is that right? Including the what you heard from outside, is that right? On top of that, I see. Yeah, but you don't change any outside audio.
No.
No. Yeah. So it's on top. It's kind of reminding what's going on inside the system. Yeah.
For example, when this music was playing, I mean, you would hear, I mean, that microphone captured, I mean.
Yeah, the microphone captured that. And so there's a lot of, because it's a pre-built
I
microphone.
mean, what's the effect of, for example, what's the effect of that music on on the system?
So it will, because of the auto gain that's already implemented there, it will detect the sound, like output from the speaker, and it will set it at a level. And so after you speak, let's say, I would say like 5 seconds after that, it would kind of like auto level. And so if I speak normally right now, it will kind of look like a smaller sound wave compared to what it was showing on the speaker. So the speaker, that's why whenever we were speaking, everything was peaking on the visor because it's just detecting our sound as the peak level. But once we do something, let's say a lot higher, it auto gains, and then it sets that as the level. And so everything below that would be a smaller sound.
All right, Dr. Young. I'm here to speak. Yeah, thank you.
Yeah, thank you. I have one question. So I noticed that you have multiple PCB board in the back. So I wonder why you don't put everything on one PCB board. Actually, that will be make everything more organized, right?
Yeah. That's a good question. Go ahead.
Dr. Weeks recommended to have modular PCBs because in case we mess up, it's easier for us to like
Troubleshooting.
troubleshoot and fix it. If we have a giant PCB, that's gonna cause a lot of problems. It can like cause EMI issues because let's say, for example, I have 2 regular PCBs inside that giant PCB. The inductor can emit a bunch of EMI, and that's gonna affect with it's gonna affect the MCU's antenna and cause data corruption, and it's too risky. So we just went with Dr. Weiss's recommendation, which is to keep the boards modular.
Yeah, sure. Next time perhaps it will be better to use some sockets. Yeah. So jumping wires will cause a lot of problem, but it's good that it works well. Yeah.
Exactly.
Cool work.
Because this is the first time they're doing the PCB. A lot of part can go wrong. And so we recommend them to make a smaller PCB, a lot of them. You already see the video. And then in the end, they couldn't put it in the helmet. but we just to approve the concept, okay, do the demo, approve the concept. So we agree, allow them to have a bag on their everything in the bag, okay. And indeed, if they have another 3 weeks, and they probably can shrink it and finally everything put in the helmet. But I can tell you, 5 days ago, it's not that beautiful, okay? It's almost thought that this group will fail. And the last 5 days, and they really do a great job. And now it's great, yeah. And for all the review, that's no question for them to graduate, all right? Okay, thank you very much. Really. Yes, please. Appreciate it. Okay. And congratulations. Yeah, very nice work in the end. The last 4 days make a huge difference here, right? Congratulations. Okay.
I told that I have to fill out.
You can fill it up here and then take a photo, email to me. That's all.
Tomorrow is okay, right?
Yeah, tomorrow is okay. Yeah, no problem. Yeah. All right. Congratulations. Okay. Thank you. Thank you all the review. Really appreciate it. Yeah.
Thank you.
Yeah.